Okay, we are going to continue on with the factoring. We looked at the general uh, strategy for the factoring trinomials before. So, when we go back to the factoring trinomials, it's going to be just x squared plus bx plus c. We didn't have any coefficient in front of the a. But whether you have A in the front or not, okay, the strategy is going to be pretty much the same, right? So I am going to write factoring trinomials. Oops. Okay. So this one has ax squared plus bx plus c. So the only difference here now is going to be we have a in front of it. So if I have, for example, you got 3x squared plus 14x plus 8. Okay, so now we have more than one a way to factor the 3x squared. So we can have not only xx, but you can have either 3x or up and down. It's going to be a little bit different here, but yeah, one way we can do that is going to be 3x and x. Oops, excuse me. I'm going to change this. We'll have 3x, then x over here. Now, 8, we can have what? We can have 2 times 4. We can have 1 times 8. So you can choose either one, but we're going to have to end up with a 14 in the middle. So I would probably go with something like 2 here and 4 down here, and both positive. If I vertically multiply, right? If I have multiply, so I got 3x times x, I get 3x squared. 2 times 4, I get 8. Now, if I cross multiply and add, see what we got. So here, if I multiply this way, I get 2x. And if I cross multiply this way, we have 12x. Now, if I add both of them, we get 14x. So that's what we have in the middle here, right? So this is a good combination. So now we're going to have to write it as a factor form. We got 3x plus 2 times x plus 4. Now, the one way to find out whether your factor form is correct is just to multiply these two factor forms using box if you want. Okay, so we have 3x, 2, and x and 4. So you got 3x squared, 2x, 12x, and 8. So we have what? 3x squared, 2x plus 12x, we get 14x, and the plus 8. That's exactly what we started with. So because you have a coefficient in front of the x squared term, it's not going to make any difference. You're still going to have to, factor the polynomial as we did before. You're just going to have a few more terms to try before you actually come up with one. So here's another example. This time it's not so much you're going to have just the one, but you can have more than one combination of the first term. So what if you have something like this? You got 12 x squared minus x and minus 6, right? So if you look at this one here now, 12x squared, we can have several ways. So you can have like, 4x times a 3x. Or you can have 6x times a 2x. Or you can have a 12x times x. And so those are the three choices that we need to look at and select one, right? At the same time, we have a 6. You can have 2 times a 3, or you can have 1 times a 6. So we're going to have to try the combination of these, the factor form of 12x squared and the 6, so we can come up with the minus x at the middle. Okay? So I'm guessing here, so I'm going to go like, try the closest one first. So I'm going to go 4x and the 3x. So if you going up and down, that's the multiplication, right? You're going to have a multiply. And then I'm going to try 2 and 3. But I'm going to be careful because I need to come up with a minus x in the middle. So I'll probably go something like this. 3 and 2. This one has to be minus, so you're going to have a big one's minus. A smaller one is going to be positive. Now remember, we're going to have a come up with a minus in the middle, right? So let's just cross multiply and add, see what happens. So here, if I multiply this way, I get minus 9x. And cross multiply this way, I have 8x. Okay, so if I add these two, I get minus x. So the factor form here is going to be 4x minus 3 times the 3x plus 2. Now, once you put them into the factor form, if the factor form is not completely factored, then you're going to have to do another factoring. Okay? So what I mean by that is that if you come up with the, once you do the factoring, let's say one of the factor form is, let's say 4x plus 2 instead of a 3x, then common factor is going to be 2, so the 2 has to come out to the front. Okay? So it has to be completely factored. Now, so someone asked me, how do you know, right? Which one to choose, which combination, you're going to, how do you know which one to choose in terms of, the factor forms? Well, you're just going to have to try a couple of them, okay? There is no, right way or the wrong way. You're just going to have to try, see if that thing works or not, okay? So that's the, the book called the trial and error, and that's probably what it is. You just cannot know what would be the which combination would work, so you're just going to have to try. Hopefully, what I'm saying here is that you always want to try the closest one first. Now, if there's a combination of two numbers that are close to one another, I'll probably try that one first, okay? And then the number that are further apart, like 1 and 6 in this case, 12 and 6, I'm probably not going to try until the end. But I'm always going to try the two numbers or two variables that are close to one another, and then I'm going to try that first. And then if that doesn't work, then I'm going to go down to the some other combinations, because about 80% the closest one works. I'm not saying they always work, but sometimes that even though they are not close to one another, they still work. But my strategy would be I'm probably going to I'll try the closest one first, see if that works. If not, then, I'll probably want to try. Okay. So, so if you have the coefficient in the highest term is like big, you're going to end up with the, many different combinations. So you guys going to have to watch out for the which combination is going to work and which one is not going to work. Okay. Let me try one more here. So this one's going to be, yeah. So this time I have what? Minus 14x squared plus 29x and the plus 15. Again, we're going to have to look for the combination. We got 14x squared here. So I can say minus 7x times 2x. Or I can have a minus 2x times the 7x. Okay. Or I can have minus 14x times x. Or I can have a minus x times minus 14. So we got quite a few combinations that we can try. Now for the 15, I can have like 5 times 3. Or I can have a 15 is equal to what? 15 times 1. So those are going to be the two combinations. Again, I am going to try the one that is close to one another. Now remember that we're going to have to end up with the 29x in the middle. So we're going to have to try the, couple of, combination here. Okay, so let's try the, I don't know, closest one is going to be, minus 2x and 7x. And I'm going to try the 15, 5 times 3. Okay, so if I try the minus 2x, okay, it might work. So I'm going to try this one, minus 2x, and I'm going to have a 7x over here. So I'm trying this guy here. Okay. Now for the number over here, constant, I am going to try maybe like, 5. Okay. And the 3 by 3 has to be minus, right? Now the problem here is that we have 5 times the 7x. If I cross multiply, I get 35x. Then minus 2x times minus 3x is going to give you a positive 6x. So you're going to get 41x instead of 29x, right? So this is not a good combination. So we're going to have to try another one. Okay, so this time we failed to select the right one. So this time then I'm going to try minus 7x and the 2x. Now we still want to use the 5 and 3. Okay. So this time I'm going to have 3 and 5. Okay. Now the problem here is that I'm going to have a minus 35x. Okay. I cannot use the minus sign here. So we might have done something wrong. Okay. With the first one that we tried. Maybe I was right. Hang on a second. I'm just going to rewrite this. So let's try the 7x here, then minus here. Okay. So instead of putting minus sign here, why don't we just put the 3 and 5 here? Let's try and see if this combination works. So if I cross multiply like this, I have a minus 6x. And if I cross multiply like this, I get positive 35x. And if I add these two, I get 29x. Well, that's good. That's what I need in the middle, right? So the factor form is going to be 7x plus 3 times minus 2x plus 5. Okay? So as you can see, you might want to try a few different combinations. You might, because sometimes, if you get lucky, then you will get the right combination. But if not, you might end up with the different middle terms. So you're gonna have to try maybe one or two, possibly 3 times of trying these combinations. Okay. Now there's another one here is that we call the substitution. In other words, that instead of having square, now you get something like like this: 2x to the 6. We've never seen this before, right? Minus x cubed minus 15. So here we're going to have to use a substitution method. Okay. So what I'm going to do here is that I'm going to call the x cubed is equal to q. Then you know that x to the 6 is going to be the q squared, right, by exponential rule. So if I rewrite this, I'll have a 2 q squared and minus q minus 15. One thing that we have to remember is that when you finish the factoring this, you're going to have to go back to replace that with x, because we started with the x, right? So here, 2q squared is going to be simply 2q times a q. That's okay. Now the 15 here is going to be just going to be 5 times 3, or 3 times 5. Or 15 is going to be equal to 15 times 1. So let's just rewrite the first term. We got 2q and the q. Here I am going to try the 5 and 3. So I'm going to do it this way. 5 and 3. Because I need to end up with a minus in the middle, I'm probably going to negative here and positive over there. Why? Because if I multiply this way, you get negative 6q, and this is going to be positive 5q, and I'm going to have a minus in the middle. Okay, this is what I mean. If I cross this way, I get minus 6q, and this way I get 5q. If I add these two, I get minus q, and that's what we need to have in the middle. Let's rewrite the term. So I have 2q plus 5 times q minus 3, but we didn't start with the q, we studied x, right? So q is actually x cubed, so we're going to replace that. Now we have a 2x cubed plus 5, and then x cubed minus 3, and that should be our answer. So I just want to mention that there is the possibility that you're going to have to do the substitution if you don't see the if you see the big exponent instead of just a square. All right. Now we want to talk about the what we call special products. Let me show you what that is. So special products. Now, special products simply means that these types of trinomials have a formula already found. So you're just going to have to use the formula to factor this. Okay, so I'm just going to show you here. Okay, so we have something called a perfect square. So the perfect square trinomials is going to be the, for example, if I have, x plus y squared, that's the same as x squared plus xy plus y squared. And if I have x minus y squared, that's going to be same as x squared. Oops, sorry, I've got the 2 in between. And minus 2xy plus y. That's what we call the perfect square. Now the other one here is that what we call difference of square. Okay, so if you have any polynomial form of this one here, like x squared minus y squared, that's going to be same as x minus y times x plus y. Because the middle term drops off, so you don't have to worry about it. Now remember that this is different than the what we just did. Parentheses x minus y squared is different from the difference of square of x squared minus y squared. Okay, so let's just look at the example of each one of them. So if I have, let's say, right, I have x squared minus 10x plus 25. So that's going to be the one that you're looking at over here. Okay. So you would have, in this case, if you actually factor this, x here, over here is going to be 5 and 5, but they both going to be minus, right? Because if you cross multiply, you got minus 5x, and cross multiply this way, you got minus 5x. So you add these two, you get negative 10x. So what you have here is going to be x minus 5 squared, and that's what you see on the perfect square. The same thing works for if you have x plus y squared. Well, let me look at the next one here, difference of square. And so here, difference of square is going to be, for example, like x squared minus 100. So you're going to have to make it look like x squared minus y squared. So if I rewrite this, 100 is going to be 10 squared. So now we have x squared minus y squared. That's the difference of square. So I can say this is the factor form, x minus 10 times x. Okay. Now, sometimes we do have the coefficient in the front. Okay, so we have 9x squared minus 16y to the 4. So if you think this is going to be look like, the difference of square, you're going to have to make it look like, right? So if I rewrite this, the 9 is going to be a 3 square, isn't it? So let me rewrite this. 3 square, x squared. 16 is 4 square. So minus, or you can use the 2 to the 4th. Okay, 2 to the 4th, and the y to the 4th, right? Now, we need to have x squared minus y squared there, right? So the first one is going to be okay because you use the power rule of the exponent. We can rewrite this as 3x squared. Now the 2 to the fourth y to the fourth is going to be a little bit different, right? Because we need to make it squared. So you're going to have to rewrite the second term over here as instead of a 2 to the fourth, we're going to make it 4 squared. Then we're going to have a y squared times the square. Like this, y squared times y squared, right? So that means we can now rewrite this as what? 4 squared y squared, right? And to the, was that 16? Yeah, okay. So you can, y to the fourth, right? So in this case, oh, sorry about that. Instead of having a square here, so instead of having 4 squared there, I mean, if you want to put this thing together, right? And we can rewrite it as the 4y squared to the square. And by the power rule of exponents, this square outside is going to be applied to both 4 and y squared. So if you multiply them, you get 4 squared, and you get y to the 4. Right? So that's pretty good. So now we have a 4y squared to the square. So now if you just look at the term, so we have x squared, and the other thing, whole thing here is the y squared there. So here that the if you use the difference of square formula there now, you're going to have what? 3x, right? That's going to be x, and the minus 4y squared times 3x plus, right? 4y squared, right? According to the difference of square. So you're just going to have to take care of the constant term as well as the variable, because you know what, you're going to have to apply the rules of exponents correctly, otherwise you're going to be in trouble. I have a few more examples here, so because there's some different types of factoring problems. So what about this guy here? 32 x to the fourth minus 2. So it seems like, we can put them into the x squared term, right? But the first thing here is that you're always going to look for a common factor here. So common factor for these two terms is going to be 2. So let's take out the 2 to the front. And you got 16 x to the fourth minus 1. Now let's just look at the 16 in terms of exponential power. So we can rewrite this one as the what is that? Is that 2? Yeah. So you can have like 2 to the fourth, right? 2 times 2 times 2 times 2, you get 16, right? Then I have x to the fourth and minus 1 to the fourth. I mean, just okay. Now, what we can do here is see if we can somehow use the difference of a square to apply to this, right? So here's what we're going to do. And so instead of using 2, we want to make this guy square, right? So just like the previous problem, we're going to rewrite this as this. So we're going to have a 4 squared to the x to the fourth minus 1 to the fourth, right? But I can rewrite the 4 squared x to the fourth, right, like this. 4x squared and minus 1 squared. Now, I mean, the 1 is not going to make any difference whether you're going to have a 2 on the, exponential power for 1. It doesn't matter what is the square root of 4, right? So in this case now, we have the x and y term that kind of follows the difference of square. So in this case, this thing here is going to be your x, and that one, the y, the 1 is going to be your y. So if I rewrite this, you get 2, 4x squared, right, minus 1 times 4x squared plus 1. Now, this one is a prime, meaning that you cannot factor any further. But this one can. So that's why I asked you in the beginning, you're going to have to factor completely. If this is also factorable, you're going to have to factor this. So you can also apply the same thing the way that we did here, using 2 squared x squared this time. Then you will end up with 2x plus 1 times 2x minus 1 times 4x squared plus 1. Okay, so that should be something that we need to remember. Okay, so that if the if you think the final factor form is not completely factored, then you want to go back and make sure that it's completely factored. Okay. Now this example is a little bit more trickier than other ones that we did, but you're gonna have to look at this one very carefully. So let's say we have the x squared plus 10x plus 25 minus y squared. So what we want to do here is that we want to look at the x terms with a constant term by itself and just leave the y squared for a moment. And so here we're just going to look at this guy first. Okay. So you know that x squared plus 10x plus 25, okay? If you factor this, you will end up with the x plus 5 x plus 5 squared and minus y squared. So once you put it into the difference of square form, then you can just use that formula here, x plus 5 and the y. So you will have x plus 5 minus y times x plus 5 plus y as your factor form. So this one's, I know that some people go, wait a minute, that's 4 terms. So how come we're not using a grouping method? You can. But if you do it this way, it's going to be much easier. I mean, but the one thing that students are going to ask me here is that now, how did you come up with the x plus 5y squared? But if you look at the x squared plus 10x plus 25, right? If you have the x plus 5y times x plus 5, you will get x squared plus 10x. the same thing. So, you know, if you want to do this using the, grouping method, that's okay. But sometimes, you know, if you do it this way, it's going to be much easier. Okay. We want to look at the other one. Here is the let me see the look at the next type. Oh, here's the here. So we have something called the sum of cubes and the difference of cubes. So we have sum of two cubes. So just like the difference of a square, this one has a formula. If I have x cubed, right? And if I have the x cubed plus y cubed, then you're going to have x plus y times the x squared minus xy plus y squared. That's the formula. And the difference of two cubes, and we have x cubed minus y cubed is going to be x minus y times the x squared plus xy and plus y. Okay, so let's just remember these formulas here. I'm just going to give you a couple of examples. Okay, so here's the one example. I have x cubed minus 27. So we need to fit it into one of these two, right? X cubed plus y cubed or x minus y. But if I rewrite the 27 in terms of the 3, you will get x cubed minus 3 cubed. That's going to be a difference of cube. So just follow it. And as you can see that here the x is going to be your x and 3 is going to be your y. So just follow the formula here. So you have what? X minus 3 x squared minus 3 plus 3x plus 3x and minus 3 squared. So in this case, we'll have x minus 3 and the x squared plus 3x minus. Okay. Now let's look at the next case here. I have 8 x cubed plus 125 y to the 6. So we need to find out, see if this thing can fit into the sum of two cubes. So I'm just going to rewrite here. 8 is going to be a 2 to the cube. So 2 to the cube, x to the cube, and 125 is going to be a 5 to the cube. And the 5 to the cube, and I'm going to rewrite the y to the 6 as the y squared to the cube. So it seems like that we can rewrite. So here's the 2x and the 5 cube y squared. Well, let's see. That was not a good one, so I'm just going 5 y squared. Right? So let's just rewrite this using the sum of cubes. x plus y, so the 2x is going to be your x. I'm going to write 2x plus, now the y is the entire 5y squared. Next, x squared means the 2x squared. Minus xy, so minus 10x y squared. Okay, and plus y squared means the 5 y squared to the square. Okay, so let's rewrite this. I have 2x plus 5y squared. And then I have 4x squared, because 2 squared is a 4. I have a 4x squared. Then I have a minus 10 xy squared. Then I have a 25 y to the 4th, because you're going to have to square the 5, right? Plus 25 y. Okay? So that should be the factor form of the 8x2 plus 125y6. So if you want to use these formulas, you're just going to have to rewrite it, so you know it's going to be look like one of these forms that either sum of the cube or the the difference of the cube. Now, as I mentioned that if you have any type of polynomial, the first thing that you want to do when you want to do a factoring is look for the see if there's any common factor there. Here's a typical problem, though. Many of you probably go, "Oh, I'm going to have to rewrite this as one of these given formula forms." But yeah, but if the numbers are getting big, you don't want to do that. See if unless you have if you can find the factor form and make the remaining smaller, so you can use one apply to one of these formula. Otherwise, it's going to be pretty big. So here's the one example: 27x cubed. Then I have a minus 216 y to the 6. Now you could try the 27 based on like 3 times 3 times 3, but if you look carefully, you can take out the 27 as your factor, common factor. So if I take out the 27, I have x cubed, and the 216 is just going to be a minus. It's going to be 8. Because the 8 times 8 times 8 is a 216. Now, let me rewrite this one more time. So now I have a 27. I got x cubed minus 2 to the cube and the y6. So similar to the what we just did here. And what we're going to do is that we're going to rewrite the y6 as the y squared to the cube. So we got 2 to the cube y squared to the cube. Okay, so what we have now is that we got x cubed here, and the y cube is going to be simply the 2y squared. Okay, so if I rewrite this, you got 27 x cubed minus 2y squared to the cube. Right? Because it's a cube, you're going to have to take out to the exponent outside. Now, we have x cubed minus y cubed here, so we're just going to follow the formula here. So 27 Okay, so you got x minus y. Okay, that's what the first one is. Now the x squared is the x squared plus, right? Xy means x times 2y squared, so that would be a 2xy squared. And then the 2y squared simply means 4y to the 4, right? I mean the 4, yeah, because the you got x squared plus 2xy squared. Now you got 2y squared to the third. So what we got here is the what do we got? Square. So 2 square means a 4, and the y to the 4, right? Because 2y squared, if you square this, you get 4. 2 squared is a 4. And y squared, if you square them, you get y to the 4. Okay? So this is going to be your factor. Now, is it possible to factor any further on the right hand side, or is it just a prime? I don't want you to spend more time to investigate, see if this thing is going to be factorable. On the right hand side, probably not. I mean, you can try, but it's not going to. Right? So how do you know that? Well, just chances are that after you put it into x squared plus xy plus y squared, you may 90% of the that polynomial is not factorable. Okay, so that's going to be the using formula to factoring the polynomial here. So if you can somehow find that one of these polynomials, you can fit it into the formulas that we talked about, like difference of square, right? Perfect square, or the sum of cube and difference of cube. And if you can somehow put them into that formula, then you should be able to use the factor form of the formula right away. So you don't have to worry about spending a lot of time to going over the trying to find the combination. Okay. I want to talk about one more thing here before I finish. So let me see what we got here. Let's see. Here. Okay. So I have this problem here. So let's do this one more. So this problem is, we want to factor 6x cubed minus 4x squared and minus 24x plus 16. Okay. Again, we're going to look for the common factor. So in this case, we can take out the common factor of 2. If I rewrite this, I'll have 3x cubed minus 2x squared minus 12x plus 8. So now we have 4 terms here, right? So in this case, we want to, if you want to use the grouping method, that would be great. Okay? So let's just use the grouping method, see if you can come up with, you know, two factors that we need for the grouping. Yeah? So I'm going to combine the first two and the last two, and these two. So here I have 2 times, I have 3x cubed minus 2x squared minus 12x minus 8. You have to be careful with the sign of it. Okay, so what we're going to do here is now we're going to look at um, you know, what's the common factor here. So I'm going to put them into the bracket, the green bracket. The common factor here is going to be x squared. So that means the 3x minus 2 minus. Now the common factor of the 12x minus 8 is just going to be, okay, so that will be 3x minus 2, right? Okay. So if you look at the two green brackets, you can see that 3x minus 2 is going to be your common factor. So 2 times the 3x minus 2, and the other one is going to be x squared minus 4. So that's going to be factor form. But this guy over here, we can also completely factor, right? That can be x plus 2 and the x minus 2. So this is going to be a difference of square. And if I use the formula from up there, and there should be x plus 2 and the x minus. Okay? So, as I think I mentioned before, if you're not sure, you can always multiply this and see if you can end up with the the original polynomial. And if you get it after multiplication, and that's the right factoring polynomial. Okay. I am trying to find the one problem. I don't see that there. Anyway, so we will. I'm going to go over some general strategy next time, but pretty much, whatever we talked about last time and today, that's going to be pretty much based on what the factoring strategy will be. There are some other strategies that I'm probably going to tell you next time, but it's going to be pretty much what we talked about there. Okay, common factor grouping and trinomial factoring, and special products, difference of square, sum of cube, difference of a cube, and those are going to be the pretty much cover everything when you try to factor some. All right. So I'll come back to next time, and if I'll probably have one or two more strategy that you can use. So we'll talk about that, and then we move on to the polynomial equations. More of the application problem, word problem based on the polynomial. Okay, we'll talk about that next. All right. Thanks. See you later.